The lesson outcome for this video is I can graph quadratics when given the x-intercepts. Alright, so before we get into that actual full goal, we're going to do one example where we know more than just the x-intercepts. We have those right here, but I'm also telling you the vertex in this one so that we can kind of see what happens on the graph because of where my x-intercepts are. Alright, so let's start by going through and plotting our x-intercepts. -2, 0, so -2 on the x-axis and 0 on the y-axis will give us this point right here. And then 4, 0 is this point right here. So those are where my two x-intercepts are. Now if you think about what we've been talking about in class recently, we've been talking about how a parabola is always symmetric. Right? Symmetric. So if I have a U-shaped graph, this vertex is in the very center, sorry that's really messy, but the center of my parabola, and it would be make both sides of the parabola symmetric. Now, think for a minute about where the x-axis would cut through the parabola like that potentially, and how these x-intercepts are a certain distance away from that line of symmetry. Maybe you've noticed this, but if everything's symmetric, that means this point is going to be the same distance from the line of symmetry as this point, which means that our x-intercepts are evenly spaced from the line of symmetry. And so if we go back to this graph here, we know that our line of symmetry is equally spaced, or in other words, in the middle of our two x-intercepts. Well, if we think about, here's our two x-intercepts coming in towards the center until they meet, what we're looking for actually is the average of the two numbers where those x-intercepts are to find the middle. Okay? We could kind of eyeball this if we move in 1, 2, 3 from that point, and we move to the right 1, 2, 3 from that point, we notice that this is the direct middle between those two x-intercepts. Well, guess what? That will always be where our line of symmetry is. So x equals 1. If I put that line of symmetry in here, you're going to see that it's always going to be directly in the middle of our two x-intercepts. And then our vertex we know is on that line of symmetry. We know that. Okay, so 1, -9 is where our vertex is. So 1, -9 is right in this region here. That's our vertex. And then the branches of the parabola will open up from that vertex to the right and through that x-intercept, and then to the left and through that x-intercept. Okay, so what I really want to make sure you're seeing here is that if we know our x-intercepts, we can very easily find the middle of our x-intercepts by averaging them. Let's talk about that for just a second. If we said that this number here was -2 for our x value and this number was 4, do you remember how to find an average? Okay, if you had a 80% on the first test and a 80% on your first test and a 90% on your second test, your average is, well, you add them up, so you get 90 plus 80, and that's 170, and you divide by 2, and that's 85. So we find an average by adding the two things up, and then dividing that answer by 2. So if I put -2 here from this x-intercept, and I put 4 here, what is -2 plus 4? Well, it's 2, and then we have to divide 2 by 2, and 2 divided by 2 is 1, and that is our line of symmetry because it's directly in the middle of these 2 points. All right, now on the next example, I'm going to show you how that is a useful thing to notice. Okay, so here we have a quadratic equation. I keep coming back to this. We know it's quadratic because our degree is 2, because that's our exponent right there. This is a quadratic. We've actually learned how to factor a quadratic expression in our previous unit, and we'd pull that 7 off to the side, list all of its factors, find the ones that add up to -8, and then we could factor it. We're not going to do that right now. What I'm going to tell you is I'm going to tell you that I know the x-intercepts for this function are 1, and 7. I'm going to go and plot those points on my graph right now. So 1 is right here, an x-intercept of 1, and 7. So like I talked about on the previous slide, if these are my x-intercepts, what do we know about the vertex? Well, we know the vertex can be found by finding the middle of this, which will help me lead me to that line of symmetry, and then using that x value, I can find my y value. Okay, so like it says, using the x-intercepts, the x value of my vertex is, so we're going to add our 1 and 7, our two x-intercepts, and 1 plus 7 is 8, and then we're going to divide that by 2. Remember, we're finding the average of our x-intercepts. 8 divided by 2 is 4. So I now know that the x value of my vertex is 4. I can put that right here. My vertex is 4 comma what? Okay? So I can start by putting my line of symmetry down the line where 4 exists on the x-axis, so where x equals 4. And now we know that our vertex is somewhere on that line. All right, so how are we going to find the vertex? Because this time I'm not giving you that value for the y. So let's look at this little table down here. We've been graphing with a table for a while now. And what we usually do is we put the value in for x and we find the output for y, put a value in for x and find the output for y, and so on and so forth. Well, we're going to use this table right now, but we are going to simplify it just a little bit. We're going to put in these two spots if there are two x-intercepts, and there will be some examples where they're not, and we'll talk about those later. We're going to write our x-intercepts in here. So we have our x is 1 and y is 0. It tells me that right here. And our x-intercepts will always have a 0 for y because it's on the x-axis. Our second x-intercept is 7, 0, because it tells us right here, 7 on the x-axis, up or down 0. What we're going to find here is our vertex. So far, we already know that our vertex x value is 4. We found that right here. By averaging our x-intercepts, we found the y value is 4. Well, just like when we graph using a table, this is pretty straightforward. We just need to plug this value of 4 into our equation and find our y value. That will tell us our vertex. So I'm going to put the 4 in for x here, and I'm going to put the 4 in for x here, just like we have been doing in class. And I just realized that this is a typo. Sorry about that. This should be an 8 right here. Okay, notice, again, I'll show that again. This right here is right here, and this 8 should be an 8 right there. All right, so now we're going to simplify. So we know y equals 4 squared. Be careful, it's not 8. 4 squared is 16. Minus 8 times 2. Well, 8 times 2 is 32. And then plus 7. Well, 16 minus 32 is negative 16. And negative 16 plus 7 is negative 9. All right, so if we know our y value is negative 9 when our x value is 4, we can say that this value here is negative 9. We can also fill that in down here in the chart, in our table. When the x value is 4, our y value is negative 9. So now we'll go ahead and plot that point, 4 comma negative 9, which is right here. And we are able to graph our parabola.